So shall we kickstart things? So I leave it to you, Emil. Good luck.
Thank you very much. Really happy to be here. My name is Emil Kvarnhammar. I work for TrueSec, and I guess many of you have heard about us before. If you haven't, we're a IT security or cybersecurity company focusing on security in general, but I mean everything, info security, technical IT security. We do secure development, secure IT infrastructure, and we also have a couple of managed services that are right now launched last year, late last year and early this year. But I'm not here to talk about TrueSec. I got the question if I could go here and talk a little bit about security in software development lifecycle with regards to containers. I think we have some really interesting experience from our security reviews, both with regards to development projects in general, using Docker, for instance, but also in container as a service and OpenShift setups, mesos, homebrewn Kubernetes configurations. So I hope you find this interesting. I'm not a Kubernetes expert. I'm in the security field. We meet a lot of different platforms and tools. So I'm pretty sure most of you know a lot more about using Kubernetes than I do. But I think this is interesting from a containers perspective in general with regards to security. So in theory, what's containers about? You already know this, but it's basically about creating containers from some kind of images. And the images are compiled out of a base image, some operating system packages on top of that, and finally the application and the application middleware and some third-party components, etc. The containers are launched on top of Docker in most scenarios. I guess, is anyone else using other things than Docker?
A little bit Rocket.
Rocket? A little bit, yeah. We played with that in CoreOS a couple of years ago, but...
Are we running everything in CoreOS?
Oh, yeah, interesting. Are you running Fleet or Kubernetes?
We did in the beginning, before Kubernetes came out.
Okay, yeah. Saw some strange issues in Fleet before, but all right, interesting. And finally, a host OS kernel. You know already know about that, but in reality, what's happened the last few years is that the application security scope has changed from dealing with third-party libraries and the application code itself to actually taking ownership from a dev or DevOps perspective of not only the application code and third-party libraries, but also operating system packages and application server middleware software. I think this is the case in most projects or product maintenance teams, even if they're not using containers, that you leave most of this up to you leave most of the lifecycle management of these components up to the development team or the DevOps. So in security, it's always interesting to talk about what are the input sources, because input sources leads to some kind of attack vectors. So in most setups, you have some kind of private registry. How many have a private registry? Yeah, all of you, almost. And you retrieve your images from the private registry into the nodes or the hosts. So what's in the registry? the Docker images. So what's in the Docker images? There are some various different input sources that leads to, from an attacker standpoint, interesting attack vectors. So we have some kind of base image from an attacker's perspective. How do we gain control of that? So that's typically some kind of GitHub project. Who's the maintainer of that GitHub project, etc. Operating system packages on top of that. How's the packages retrieved? Is it from an internal satellite server, or is it retrieved from some package server on the internet? Can we intercept that communication or install malicious software on the package servers? And of course, the application components itself. And that's, as I talked about before, that's not only the code that we developed ourselves, but also the third-party libraries and middleware, etc. So in that case, if it's Java, for instance, it might be a Nexus repo, hopefully. If it's not, then it might be Maven Central, and then it might be possible to do build injections on the build process if you can intercept the communication from Maven Central, for instance. But the input sources to the images are not only the interesting attack vectors, it's also about how configuration reaches the host environment. And of course the registry itself. How many of you have a secure private registry set up? What do you think is a secure private registry? Anyone?
Well, we're running it inside Amazon. So in the same VPC that we have on Amazon, that we have our Kubernetes clustering, and we are using TLS between it. That's about it.
Good. So we'll revisit on that. You have TLS, etc. We're going to talk a little bit more about that later. But even more, one interesting part is, from an attacker standpoint, if you gain code execution within a container, that itself could mean that you have a possibility to reach out to the registry or to reach out to the host or to other containers within the same host. Because that's what people typically think about private registries. Our registry is behind a firewall, right? But that's not a secure registry. Because typical attacks starts with the applications. Utilizing some kind of application vulnerability or middleware vulnerability. Like maybe you read about during last year, there were 2 critical vulnerabilities in Apache struts, for instance. That was extremely easy to exploit, to gain code execution within a Java application. And once you have code execution or command execution within the container, from there you can reach the private registry in most setups. So think about this. Go home and think about, would that be possible if an attacker potentially gets code execution within the container? Does that mean they would be able to push code to the private registry? And from there, another node within the cluster might pull the same code. So a firewall wouldn't help. HTTPS or TLS wouldn't help either. Even authenticating the users and saying that only authenticated users are allowed to access the registry, that wouldn't be sufficient either, because these nodes, they are supposed to access the registry, right? So it's important to distinguish between the access rights or the user credentials that are supposed to be owned by the node versus what's supposed to be reachable by the container itself. Because it's the Docker daemon, right, that needs to reach the registry. But limiting the access rights. So if you make a difference between, for instance, the user credentials that the node uses to retrieve the Docker image versus the user credentials that someone from a workstation or a CI/CD environment uses to push new images into the registry, then that will solve the problem. And also, I think it's good to look at Docker Content Trust, even if it's a bit complex to set up. It's still very useful to trace the origin of the images to make sure that these images hasn't been modified since they were produced by dev or DevOps or CI/CD or what have you in your typical software development lifecycle. Even worse, if someone gets code execution within a workstation or a CI/CD environment, then that would lead to an even worse situation, because there you typically have the credentials that are sufficient to push code into the private registry. So think about a stolen or lost laptop, for instance, what that means. And make sure you rotate those access keys or credentials if somebody quits their job or things like that. So how malicious code reaches these workstations, that's not different compared to how malicious code reaches machines in general. Typically phishing attacks, maybe some tempting tool that the developer downloads, and all of a sudden you have malicious code in your dev environment. So firewall doesn't help in this situation. TLS doesn't help. Oops. My remote screwed up. I think it's when I move it that way. Try to avoid that. Authenticating the users wouldn't help, and limiting access rights is insufficient. Even Docker Content Trust might be insufficient, since the keys for signing the images, assuming if the keys for signing the images are within that workstation or CI/CD environment that we're gaining control of. So this is about securing the software development lifecycle and making sure that we handle each building block, and especially machines that have sensitive credentials or powerful credentials to the environment. What are the skills needed to inject code in an image? You know all this, right? It's extremely simple. It's just like simple commands and modifying a Docker file and pushing a new image. A kid could do that. So over to the runtime environment, even if it's slightly out of scope for securing a software development lifecycle, there are a few operations people here. I think you might find it interesting to look at what we believe is best practices in secure configuration of a Docker engine and Docker runtime environment. Have you heard about user namespaces before? How many are using it? Not that many. Yeah, it's quite good separation. It's not a silver bullet. We'll get to silver bullets later, but it's still some kind of separation where you don't have root within the image or container equals root on the host machine. We need more than that, but it's a good practice to separate the user accounts. And of course, the remote API of the Docker daemon or Docker engine is good to secure or turn it off if you're not using it. SE Linux, unfortunately, a lot of images or standard images still have SE Linux to permissive by default. I really recommend using SE Linux to enforcing because it catches a lot of like lateral movement between containers and from container to host, etc. So if you're not running in enforcing, I do recommend that you do so. And this might sound as overkill, but really, if you're not using these capabilities of Docker, just drop it. And only pull from private registries. If you're only using private registries, there's no reason why you should be able to pull from Docker Hub, for instance. And think about dedicated physical hosts for critical applications. Because think about Meltdown and Spectre. No one missed this, right? If you're running on the same kernel as other containers, you have to assume that other containers could reach your environment. You guys already know this. Containers are not virtualization. Conceptually, it's similar, but technically, it's not the same. Anyone disagrees? And what about large-scale deployments or clustering? That's what you guys are into, right? Security in clusters is really about like copying this complexity and making several instances of the same problem to some extent. In cluster configurations, you typically have some kind of agent and some master nodes that are not really workload nodes, but only responsible for maintaining the cluster. This is a bit different in depending on what kind of cluster environment that's being used, but usually you have some kind of networking. I guess most of you are using Flannel, or sorry, something else. Sorry,
Calico.
Calico. I haven't heard that. Oh, yeah. Okay. And you have peer networking between cluster master nodes, like maintaining the cluster, the setup of the cluster. And we noticed when we have made security reviews of this type of configurations, we noticed that it's possible to actually just join the cluster from the outside. Sometimes we might need some kind of shared secret, but we can usually retrieve that shared secret from the source code repository, for instance, or from a development machine, unfortunately. So assuming we have the shared secret, sometimes that's not even needed. We just need the IP address of the cluster nodes. Now, all of a sudden, we're part of managing the cluster. No logging, no admin accounts, nothing. So it's extremely important to identify all these attack vectors, especially on the infrastructure side of things in Kubernetes and CoreOS or whatever. Like admin user interfaces and API interfaces, all of these are typically interesting for attackers to gain access to these, and investigating what credentials that are needed does this even require user authentication, for instance? Yeah, so this is just a mess. And now it's time for the silver bullet. So, some things that I think you should avoid. I hope no one is using privileged. If you're using privileged, stop using it, because this is extremely trivial to break out to the host from a privileged container. Don't use insecure registry, because that means you turn off everything with regards to TLS and secure data in transit of Docker images. And on that subject, I just realized that I have something interesting I wanted to show. Is anyone using this Kubernetes Addon, the Registry add-on? I just found it a bit funny that it said how it works. It does not currently support SSL or authentication, which triggers Docker's insecure registry login logic. To work around this, we run a proxy in each node in the cluster, exposing a port on the node, which Docker accepts as secure since it's accessed by localhost. That's a great idea. Circumvent the security. I think somebody at Docker thought that this insecure registry flag should be like clear enough, but obviously not. Avoid using the host network stack, because that's a bad practice from a security standpoint. I think it's very important to keep, that's in general, whether you're using containers or not. If you're just running on Amazon, for instance, keep your machine stateless and keep your container stateless. Because if you do, it's a lot easier to upgrade and maintain, disaster recovery, everything. Limit the file system writes in your image. Use distributed sessions and caches. Nothing that's stored locally on each of the workload nodes. Avoid mapping host volumes, because as soon as you do, I bet you're gonna store stuff, credentials, etc. that's gonna be needed on these nodes, and all of a sudden it's wiped when you like lose hard drive or like get data wiped for another reason. Aggregate logs, of course. Oops, there we go again. Almost missed my happy cat. This is going to make it more secure. It's going to be a lot easier to upgrade, disaster recovery, whatever. And be target agnostic.
Okay, if I interrupt?
Yes.
Regarding mapping host volumes,
Yes.
How do you suggest injecting secrets into the containers?
Yeah, that's a very good question, because you can't have it in the image, right?
Right.
Yes. So
Host volumes is one of the common methods, right?
yeah. So if you're and of course there are exceptions, and that's a good exception. I'd rather generate like RSA key pairs locally on the host and avoid sending it to the host. So that would be a good exception for that. But in that case, it's good to use SE Linux and use the correct labels so that it's only that container that can read and write the files. And be target agnostic, because things might change, right? Even if your target environment is the perfect environment today, you might want to move to AWS Fargate or Azure. I don't know if anyone's running Docker on Azure, but at least they have the possibility to do so. So it's important to let's look a little bit closer on how to secure your registry, because we want to be able to both push and pull images like we talked about before, pushing from the development environment and pulling into the production environment. It's important to have TLS in place. That's a kind of a minimum. We talked about that. What's a secure private registry? That's number one. Make sure you authenticate users. And a node, a server, is also a user. Don't just allow anonymous access even for reads. Limit the access rights. Damage control. And use Docker Content Trust, because then you can make sure that this image has not been modified while in the registry or while traveling between the development environment and the production environment. So, securing a software development lifecycle with containers is about securing the development machines, taking control over how third-party components and base images and packages reach your CI/CD environment with access control, manual review of what's being changed, for what reason. In our development projects, we even diff what's been changed on a bytecode basis to understand how a certain change is reflected in the produced output. I understand that it's not realistic in all development projects. That depends on security requirements. And maintain a good base image, a golden image. And don't rely on that, okay, if the base image that we are using as a source hasn't been updated, then we're using the latest version. Because sometimes security patches only reach the package servers without the base image being updated. But if you build that into your CI/CD environment and have triggers not only for that the source code has been modified, but also that the base image or the operating system packages has been updated, and the middleware, if you have third-party components in Nexus, for instance, if you have multiple triggers, then you ensure that your containers are always kept up to date with the latest configuration and the latest software available. And then as many automated tests as possible. Automated tests on code itself, of course, but also on the image configurations, the assumptions you make from an application point of view on your Docker image. Make sure you verify that continuously. And there are tools available that can scan your Docker images for known security vulnerabilities. Take a look at OpenSCAP, for instance.
What about Claire?
Excuse me?
Claire.
I haven't used that, but I have only read about it. But there are many different tools that like submit or retrieve what packages that you're using from a vulnerability database. What differs typically, like in general, that's not Docker specific, but in general with tools like that, what usually differs is the size of the lag between vulnerability being discovered and actually reaching that database. So that's important when evaluating such tools. And finally, producing signed images and ideally push that to a separate private registry that's only being used by the staging or production environment. So to summarize all this, Docker changes a lot. You already noticed that if you've been using Docker for a while. And it changes how software reaches production. That's why it's so important to secure the entire software supply chain, not only the code we develop ourselves. With Docker comes many new attack vectors. With Kubernetes comes new attack vectors. Unfortunately, it's not always to the better when we develop and invent new stuff. think about lateral movement, both between containers within a host, but also within the cluster, and even from the cluster to the outside and the rest of the infrastructure in your environment. Think about all this from an attacker's perspective. If you do, then it's all of a sudden very easy to realize what's the weak spots in our environment. And securing your software development lifecycle is about maintaining a base image, the golden image, setting multiple build triggers, using Docker Content Trust, automated tests, and perform continuous security testing and vulnerability scans that I talked about. That's about it. Thank you.
Do you have any experience with repositories or where you, like Quai, for example, where you have built-in vulnerability scanning? Do you have any experience with any of those kind of tools that you can say something about?
Not that much in terms of using, but testing.
Yeah.
We have seen a couple of different setups, like Nexus, for instance, have one way of doing that, and I think a couple of years ago, more or less the only option was to use the community variant, like of the registry, and that was extremely complex to achieve good security with. But I think it's important when you evaluate products for the registry function, it's important to look at these aspects. Is it easy to create user accounts? Can we authenticate even with certificates or some kind of API secrets? And can we limit the access based on what's needed? For instance, for a node retrieving the images and for the producer part that needs to push images. And there are registries, like I think that's built into or about to be built into OpenShift that automatically updates to the latest known available image online. That's very similar how Nexus works with Maven Central integration, for instance. Okay, so who's next?
It's me.
It's you.
Right.